In this video, we will go ahead and build a simple regression model. So, as we know, our supervised learning algorithms are divided into classification problems and regression problems. In classification problems, we have discrete value output, whereas in regression problems, we have continuous valued output. So, of course, the first step to any problem solving is to import all the necessary libraries. Here I am again using TensorFlow.keras. And also I have added one more library, one more class of my library NumPy, which is called as sqrt. So we will be working with the Boston housing price data set. I hope you are already familiar with the Boston housing data set. So it has 13 attributes or 13 columns, and the 14th column is actually the median value of owner occupied houses in $1,000. So your last column gives you the price of the house or the median value of that house in $1,000. And you also have 13 attributes which we will be using in order to build a model. So if you look into the data set, we could see that you have 14 columns, and this last column is our target Y value, which is the median value or of the cost of the house in $1,000. So this is what we have to find when we provide any record, new record or test data to my regression model. So the next step is data pre-processing. So as you might have noticed here, we are not doing label encoding. Why we are not doing label encoding is that for this particular data set, as we can see, all the values are numerical values and we don't have any text values that has to be encoded. So that is not there, but all the other things remains the same as that of a classification problem. And then the final step is to build the life cycle of a keras model. As we know, the keras model has 5 life cycles, that is starting from defining the model. So as you can see, my model has got 2 hidden layers. So this is my first hidden layer with 10 neurons, the second hidden layer with 8 neurons, and then I have one output node in my output layer. Now as you can see, if this was a binary classification problem, I would have used the activation function, sigmoid activation function, for my output layer. And if it was a multi-class classification problem, I would have used softmax in this output layer. So see, in this case, I haven't used any activation function in the output layer. And the reason is that this is a regression problem. The reason why we use an activation function in the output layer in a classification problem is that in a classification problem the outputs are between a particular range, right? But when in the case of a regression problem, there is no range, because our Y value or my output Y value can be any continuous valued output, right? It can be from value from 0 to infinite value, right? Whereas in classification problem, it is bound to a particular range. Your output value is bound to a particular range. That is why in a classification problem, we do have activation function in my output layer, whereas as you can see in this example, I have not included any activation function in my output layer. But again, it depends upon the problem. There are activation according to your problem statement and the range of value that you can require. You can of course add activation function to my output layer in the regression model too. But currently I haven't used any. Right? And even if you were to use an activation function in this particular output layer, you can go for a linear activation function, right? So again, those are fine details you have to be aware of depending upon the problem you are trying to solve. The next step is to, of course, compile my model. So I have used the same optimizer Adam, and see now my loss function I am using is mean squared error, right? Because it is a regression problem. And in the third step, of course, I start to train my model for 150 epochs on batch size of 32. And once my model is trained, the fourth step is to evaluate our model. So in evaluation of our model, we evaluate on the test data, right? And then I am printing the performance of my model. So remember, one metrics, if you are using a classification problem, you can use accuracy as your performance metrics. In this case, I am using root mean squared error, which is nothing but the square root of your MSC, right? So that is where so that is why I have the square root function used or called in my libraries. In my here I have used a class square root from my NumPy library, because I am using that here to find the square root of my mean squared error, so that I can get the performance of my model in root mean squared error. And then the final step is to test your model on a new set of data. So I have already trained this model. Now because of the stochastic nature of our model, the answer you might get would be different. So it's always considered that you try to run your model 5 to 10 times and take the average of it, right? So according to the model I have built, I am getting a root mean squared error of 6.7. Now again, this is root mean squared error. That means it is an error value, and we want our error value to be as minimum as possible. So, and for this particular record we have provided, we get the median value of that particular house to be approximately equal to 30.61. So this is how you could build a simple regression model.